Right, welcome to the other session on wireless communication networks, Unit 5, that is wireless networking. Today's topic is CDMA digital cellular. CDMA digital cellular. Here nothing but this is the other than GSM technology. Instead of SIM card, we are using directly by using coding. By using coding, the particular mobile phones are allocated to the particular subscribers. Let's move to the CDMA digital cellular technology. Here the other name for the CDMA is called as the IS-95. That is Interim Standard 95. Interim Standard 95. Here this technology is developed by the scientist Viterbi and Qualcomm. Here in this topic we are discussing today what is the forward link of CDMA, what is the reverse link of CDMA, what are the special features of IS-95 CDMA, and what is the brief comparison between CDMA with the second generation standards, and what are the improvements in the CDMA technology. First, we are going for what is the forward link. Here, the forward link in CDMA technology. Here, the forward link is nothing but how communication takes place from base station to mobile station. Here, for this purpose, we are using the frequency spectrum 869 to 894 megahertz. Here, this can be divided into number of channels. For each channel, it is a bandwidth of 1.25 megahertz. The bandwidth of 1.25 megahertz. Actually, in forward link, there are 4 types of channels are available. Yesterday, we discussed about GSM channels like physical channels, logical channels. Likewise, here in CDMA forward link, the channels are divided into 4 types. The first one is pilot channel. Second one is synchronous channel. Third one is paging channels. Last one is traffic. But here, what is meant by pilot? Here, the pilot channel is used for timing purpose and phase reference for coherent demodulation and calculation of signal strength. Calculation of signal strength. Calculation of signal strength. And the second channel is synchronization channel, which is used to broadcast future state of long code register. Which is used to broadcast future state of long code register. And the third channel is paging. The paging, what is the use of paging? Which is used for call control information. In the call, what is meant call control? The call control is nothing but how connection can be takes place from transmitter mobile station to receiver mobile station. Nothing but once you have dialed the call, the signal goes from mobile station to base station. Similarly, from base station to MSC, MSC to another base station to receiver circuit. How connection can be takes place? This is done by paging channel. And the last channel is traffic channel, which includes how voice or data can be transmitted. That is, which includes power control sub channel. This is the 4 types of channels are available in forward link of CDMA. That is pilot channel, synchronous channel, and paging and traffic channel. Here, this is how exactly the CDMA or IS-95 forward link. Here, see this block diagram. It contains, see this in forward direction. First one is audio compressor, convolution encoder, block interleaver. Similarly, for other data is long code generator, decimator. It should be scrambled together, and finally it is go for multiplexing with power control. And we have to add for watch code generator, that is encoding techniques. After adding this one, we are going for PN generator, that is pseudo noise code generator. And similarly, we have to add pilot PN sequence for the Q channel. That is, here we are using in channel facing and quadrature channel facing. That is, here see what is meant by audio compression. Audio compression. Nothing but suppose we have to transmit our voice. To compress our voice, different data rates available. That is 9,600 bps, 4,800 bps, 2,400 bps, and 1,200 bps. So the 4 types of audio compression are there. After compression, we have to go for encoding with a rate of 1/2 and number of samples, which is k equal to 9. The final we are getting after compression, it is equal to 19.2 kbps. Next, we are going for block interleaver. Block interleaver by using 224 x 16 array. After this one, the second is similarly the code generated, long code generated. The maximum length of long code generated is 40 bits. After this, we have to go for decimator. After this one, to go for data scrambling. After the data is scrambled, that is here in one side we are taking code, other side we are taking audio compressor. Finally, we have to go for data scrambler. Data scrambler. Next, after going, but we have to add how much power we have to add for this voice. Once the power is added by power control bit by using mux, then we have to go for Walsh code generator. Here, what is a Walsh code generator? Nothing but this is the best encoding technique to encode then transmits to add PN sequence generator. Here, why you are using PN sequence generator here? Here is generally the bandwidth is more available in CDMA technology. The bandwidth is more available in CDMA technology, but the data is limited. That is less occupancy in the data. The remaining bandwidth is waste. At that time, we have to add pseudonymous code. Here, the adding of pseudonymous code by using PN sequence generator. Here, we are using to transmit data by using QPSK modulation. Here, what is meant by QPSK? Quadrature phase shift keying. Quadrature phase shift keying modulator. Here we have to transmit same data by using in phase and quadrature phase. Here the in phase is nothing but the same data, whatever modulation takes place, the same data can be transmitted through channel. But in quadrature phase, we have to 90-degree phase shift. Phase shift can be takes place, then transmits. This is about forward link from base station to mobile station. Here now we are discussing each and every block one by one. That is, first one is convolution encoder and reception. Here, once the audio is compressed by the rate of R is 1/2. Here, what is meant R? How many number of input bits and what is meant by divided by output bits. After convolution encoder, the output of this convolution encoder it is 19.2 kbps. Right? Here, see this one how it works. Here, what is the incoming data from audio compressor? What is the data rates? 9.6 kbps, 4.8 kbps, 2.4 kbps, 1.2 kbps. We have to take any one, then which is given to convolution encoder and reception. Here, see this one. Suppose we are taking 8 bits from D0 to D8 bits. That is 9 bits. Here, see this one by applying XOR gate. By using apply XOR gate D0, D1, D2, D3, and D5 XOR gate. Finally, we are getting G0. Similarly, for another XOR gate, we are taking another G1. That is where the output of this convolution encoder and reception, we are using G0 and C1. After the output of this convolution encoder, the maximum data rate is 19.2 kbps speed with irrespective of input. That is, we have to go for encoded. That is 9 bits too. See this one. The output of G0 is 1111 01 0 11. The output of G1 is 10 111 0001. That is, we have to encode. We have to encoding by using convolution encoder. After this encoding, block interleaver. Here, what is the use of block interleaver? We have to separate consecutive data bits or set. We have to separate. That is nothing but based upon the packet switching. Why you are going for packet switching? Instead of transmitting total information, we have to transmit the data in terms of packets. It is easy to find out errors. That's why we are using block interleaver. Here, for this block interleaver, we are using time diversity. Here, for this purpose, we are using 2 pages. One page is filled, another page is empty. Why you are going for one page is empty? The empty page is used for retransmission purpose. How to transmit data? That is that one packet can be transmitted within 20 milliseconds frame. So 19.2 kbps, that is the output of convolution encoder multiplied with 20 milliseconds per frame, which is equal to 384 bits. And data is read in a based upon rows and columns. This is about block interleaver. Next one is long PN sequence. Here, what is the PN sequence? The PN sequence is nothing but pseudonized code. What is the use of pseudonized code? To fully occupy the frequency spectrum purpose. That is, so it is sometimes wasting of bandwidth in CDMA technology. To overcome that one, we have to add a PN sequence. How much number of bits are used by the PN sequence? It is 42 bits are we are using. Next one, scrambler. This is also used for data encryption and for more secure purpose and randomized data, which prevents a long series of zeros and ones. That is the use of scrambler. Next, power bit control. It is a dynamic and decentralized and closed loop power scheme. Here we have to check in power control bit where what is the frame error rate. Frame error rate. Here nothing but suppose whenever the mobile unit nearer to the base station, how much signal strength you have received? High signal strength. At that time, we have to decrease the mobile power. Whenever you are in the long distance from the base station, nothing but the power is you are using power in mobile unit is high. That is, whenever near to base station, we are using low mobile power. Whenever long from the base station, we are using high power. Whenever it is long distance, automatically your in mobile phone charging is suddenly reduced when the distance between base station to mobile station increases. For this purpose, we are using power control. Here we have to check the frame error rate. The frame error rate is less than threshold voltage, which decreases the mobile power by 1 dB. When frame error rate is more than threshold, which increases the mobile power by 1 dB. Here in this power control, 1 bit is sent every 1.25 milliseconds with a frequency of 800 hertz. Next one is we have to add by using orthogonal covering via Walsh codes. Here the number of orthogonal channels are which is it is 64 and the matrix type here 60 cross 64 cross 64. That is number of rows which is equal to number of columns. For each row of matrix exported by 19.2 kilohertz. Nothing but we have to transmit data in terms of matrix. That is every 9 bits or 64 bits. We have to transmit access a packet. For each row 64 bits, we have to use 19.2 kilohertz per then the maximum speed for transmission is 1.2 to 88 Mbps. Similarly, here we are using channel 0 to channel 32. Channel 0 is for pilot signal. Channel 32 is as a signalization purpose. Next, we are you know that quadrature modulation QAM. Here the QAM modulation, the input data is coming. We have to add PN sequence. The PN sequence it is by using either in phase or quadrature phase. In phase by one direction, quadrature phase by another direction. Then transmits. Here the output of PN generator outputs is 1.2 to 88 Mbps. Next we are go for reverse link. Here the reverse link from mobile station to base station. Here the frequency is 824 to 849 megahertz and the channel is 45 megahertz each channel. And it is access channel. The access speed is 4800 bps, which is used for response from paging channel message and initiate communication. And for voice transmission, we are using 9.6, 4.8, 2.4, 1.2 bps, which is similar to forward link. Here see this one. In reverse link has audio compression, then go for convolution, then go for block interleaver, then Walsh code generator, next data bus randomizer. Just now we are adding a PN sequence generator, then we are going for apply QPSK for reverse link. Here also we are using QAM. QAM, that is 64x64 with Walsh code. And the data burst randomizer. When turn off the transmitter, the data rate falls below 9.6 kbps. For this, whenever the transmitter is turned off, or that we are using data burst transmitter. Next one, we are going for the special features of this Intelligent Standard 95 CDMA system. That is bandwidth recycling. Bandwidth is recycling. That is whereby adding PN sequence, and you can reuse for different cells. And power can be controlled. It depends upon the distance between mobile station to base station. And soft hand can be available in this IS-95 CDMA system. And diversity, that is multiple receiving antennas are used, block interleaves are used, rake receiver, and different types of encoder techniques and coding techniques are available in this special features of Intelligent Standard 95 CDMA system. Now we are discussing about that is the comparisons between Intelligent Standard 95 CDMA and second generation system. You see this one. The second generation was the GSM, that is IS54/136. And here the multiple access technique for second generation is TDMA/FDMA. But here IS-95 CDMA. In GSM having hard handoff, in CDMA having soft handoff. And slow power control in GSM, fast power control in CDMA. And fixed type of encoding technique is GSM, variable rate of encoding is available in CDMA. This is a 4 simple comparisons between IS-95 CDMA and second generation Cellular systems. Here, what are the possible improvements in IS-95? Increase the channel bandwidth up to 1.25 MHz using directional antennas, better power control algorithms using magnet adaptive filtering. This is a positive improvements. But today we are using only GSM technology instead of CDMA. Why? Because in CDMA technology, the bandwidth available is more. The bandwidth available is more, and we have to add sequence PN sequence generators, and operation is more compared to GSM. And installation, whatever, all our complexity in CDMA technology. That's why we are using in India. We are using GSM technology. Right. Do you have any query? Type your query in the chat box. Thank you very much for attending this session.